Welcome viewers, in this video we will see the program to find the Armstrong number using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, program to find whether the given number is Armstrong number or not. What is Armstrong number? Sum of the cube of its digits, it's equal to the number itself. If the number is available, each and every digit, if you find the cube of that, by adding that all the cube, if the again the same number come, same number itself mean it is called a Armstrong number. For example, we can take 371. So the digits 371, here the three digits are available. So 3 cube plus 7 cube plus 1 cube. If we add these three, cube of digits is the cube of the digits is equal to the number itself. So the cube of digits are added. So it is 27 plus 343 plus 1, it is 371. The same number we are getting. So the digits are taking the cube, and if it is added, if we got the same number itself, it is called a Armstrong number. Right. So what are the Armstrong numbers available up to 10,000, 0, 1, 153, 370, 371, 407, 1634, 8208, 9474 are the Armstrong numbers. Right? These are all the Armstrong numbers available up to 10,000. Now we'll see the process, how to find the Armstrong number or not. So 371, we'll take the number 371. Right. So we need to take the 3 cube, 7 cube and 1 cube. We need to extract this digit one by one. How to extract this digit? For example, we can extract this digit 1 by using the modulo division. 371 percentage 10. What is the meaning modulo division? Division means it will give the remainder value. It will give the quotient value. Modulo division means it will give the remainder value. After dividing 371 by 10, the remainder is given. 371 after dividing 10, it is goes 337 times. The remainder is 1. So we got this digit. So by using the modulo division operator, we got the last digit. So that should be cube. We need to take the cube, 1 cube. So that 1 into 1 into 1. That should be added. All these three are added together. So that we are having one variable 0. In that we are adding this value. So 1 into 1 into 1 is 1. Right. So this process is completed. Now we need to find the 7. We need to extract the digit 7. So that this 371 is reduced to 37. How it is? By dividing by 10. 371 divided by 10, it will give 37. Now 3 digit is reduced to 2 digit. Now repeat the same process. Now we need to extract this 7. So use the modulo division 10. So 37 modulo division 10 means it goes 3 times. The remainder is 7. Right. So that remainder 7, we have to make a 7 cube. Because 7 into 7 into 7. That should be added with the already available value. This 1. So 1 plus 7 into 7 into 7. That is 343. This is 343. With that 1 is added, 344. Right. Now that 37 should be reduced to single digit. So that we are dividing by 10. 37 divided by 10 means 3. Right. So what we are doing? First we are dividing the modulo division. By using modulo division, we divided by 10. Find the remainder. Remainder is cubed. Then added with the value. Second step. Third step is we are dividing by 10. So this is the process. Now we got this 3 value. Now we have to repeat the same process. So the same process repeated. 3 percentage 10 is not going anytime. The remainder is 10. We have to cube this value. 3 into 3 into 3. Already available value 344 is there. With that this 3 cube is added. So that we got 371. So this is our required answer. Right. Again what we need to, we have to divide by 10. 3 divided by 10, 0. Right. So once it is 0 reached, we can stop the process. So how to identify? We need to repeat these 3 processes. Modulo division by 10, then cube added, then divide by 10. So the process is repeated until it reaches the 0 value. So at that time we got the answer, so that if we got the 0, we can stop the process, right? So we are doing 3 steps: modulo division 10, adding cube, then divided by 10. If that while dividing it reaches 0, we can stop the process. Now we'll see the program. So the void main, open the braces, the header files we can include by default, stdio.h, conio.h. Then the variable declaration, integer n, this is a number, integer n, then this is a n, number, num, in order to store the value. This is a remainder, remainder will be stored in this variable remainder. Then sum equal to initially 0. After clear screen, we ask the user to enter the number to check the Armstrong number or not. Scan of %d n, right? So this is the number. N number also we are storing this in order to check whether n and number is equal. So the copy of the number what we entered is stored in num, right? So this is the copy of the number what we entered. Initially we need to check so that this is the given number. This given number is stored in the another variable num also, right? So that we ask the user to enter the number what we need to check whether it is Armstrong number or not. That user will enter the number that is scanned by the scanf statement and it is stored in the n. It is AND ampersand n, right? Address of n. Now we'll see the next process. So the next step is num equal to n. The number is stored in the variable n. In order to finally we need to check this value so that number is stored in n. So while n is not equal to 0, so that is our final checkup. If it is reaches 0, we can stop the process. When it is not equal to 0, we can repeat this process. Remainder equal to n %10. This is the first step what we are doing. So the remainder will be stored here. Sum equal to sum plus. So this process. Sum is initially 0. The remainder into remainder because cube of the value should be added, right? So in this the sum is initially 0. The first digit cube is taken, then it is added. In order to reduce the digit, we are divide by 10. So this is our 3 process: modulo division by 10, adding the cube of the value, and divide by 10. N equal to n divided by 10. Now the digit is reduced. The same process is repeated until when it is reaches the 0 value. Suppose if the remainder is 0, suppose the number becomes 0, that is we are using the n becomes 0, we can stop this process. When n not equal to 0, this process will be repeated. If it is 0, it will stop the process. So this value 371 is available in the variable sum, because sum equal to sum plus remainder. We are keep on adding. Initially 0, first 1 cube is added, then 7 cube is added, then 3 cube is added. So that we have 371 available in the sum. Right. Now we can stop this process when it is reaches 0 value. Right. After that we need to check. Sum. Here the answer is available. The num, the entered value n is available in the num, because now n is 0. So that the n is stored in another variable. So num equal to sum. If both are equal, mean the %d, that is the num is a Armstrong number. Right? For example, 371 means these two will be equal. So for some other number 200 or 300 mean these two are not equal. Else the print of %d is a not a Armstrong number. Right? So by checking these two values, this n is the given number. By dividing the n, keep on dividing, it becomes 0. So that the n is stored in another variable. So the 371 or entered number is available here. The answer what we calculated is available here. Both are equal, then we can say it is a Armstrong number. Otherwise it is not a Armstrong number. For example, 370 or 371 means this value will be true. Any other number 155, 158 means this is not a Armstrong number, so that it will print it's not a Armstrong number. Right? So in this program we discuss how to find whether the given number is Armstrong number or not. That is, Armstrong number is nothing but the cube of individual digits. While adding, it will give the same number itself. For example, 371 means 3 cube plus 7 cube plus 1 cube, we are getting the same value, right? So by using that, we have three processes. First to find the remainder, second one, remainder is cubed and added with the variable, then divide the number in order to reduce the digit. The same process repeat until the number become 0. If it is become 0, we can stop the process. The given number is stored in num. Check with the answer. If it is both are same, it is a Armstrong number, otherwise not a Armstrong number. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.